In this video, we'll be going over evaluating definite integrals by using substitution. Okay, so if u is equal to g of x and g prime is continuous on the interval a to b, and f is continuous on the range of g, then what we would say is that the integral from a to b of f of g of x times g prime of x dx is equal to, so this is the same integrand as we saw when we had indefinite integrals. The only difference here is that we have limits of integration, a to b. So this integral is going to be equal to the integral from g of a to g of b of f of u du. Okay, so we do the u substitution, but what we need to do is we need to change the limits of integration here once we make that substitution. So let's see how this works. Okay, so we want to compute the integral from 0 to 4 of x over x squared plus 1 dx. So our substitution is going to be, let's let u equal x squared plus 1, and then du will be 2x dx here. Now what we see here is we have x dx, but in this equation we have 2x dx, so we want to divide both sides of this equation by 2, so this will be 1/2 du is equal to x dx. Alright, so making this substitution, I'm not going to write the limits of integration just yet. So in the denominator we'll have u, in the numerator I'm going to have 1/2 du. Okay. Now what we need to do is we need to change out these limits of integration. How we do that is we could treat each of these like x values. Okay, so we're traveling, or our limits of integration, we're evaluating these from x equals 0 to x equals 4. So what we do is we just substitute in 0 and 4 into this u equation in order to come up with new limits of integration. So when x is 0 in this equation, we're going to have 0 squared plus 1, so u will be 1. And then when x is equal to 4, we're going to have 4 squared plus 1 is 17. So our limits of integration here are going to be 1 to 17. Okay, the last thing I'm going to do before I evaluate this integral is I'm going to bring this 1/2 out. So 1/2, the integral from 1 to 17 of 1 over u du. All right, the antiderivative of 1 over u is the natural log of u. So this will be 1/2 the natural log of u. I'm going to write that in absolute value. And then we're evaluating that from 1 to 17. Okay, so keeping that 1/2 in front, I'm going to have ln of the absolute value of 17, which is just positive 17, minus the ln of positive 1. The natural log of 1 is 0, so what we end up with is just 1/2 ln of 17. Okay, let's compute this integral. I'm going to let u be the inside function 1 plus 2x cubed. Taking the derivative of both sides here, we're going to have 6x squared dx. So that 6x squared dx looks close to dx and x squared here, so I need to divide both sides of this du equation by 6, so I'll have 1/6 du is equal to x squared dx. Okay, so this right here will become u. So rewriting this, we're going to have u to the 5th, and then times 1/6 du, and we'll bring out that 1/6 out here. So 1/6, we need to find the limits of integration. So when x is 0 and x is 1, what do I get in this equation? So when x is 0, I'm going to get a u value of 1. And then when x is 1, I'm going to get a u value of 3. So this will be from 1 to 3 for my limits of integration. And so I have 1/6, the integral from 1 to 3 of u to the 5th du. So getting the antiderivative of u to the 5th, we'll have 1/6 u to the 5th. The antiderivative will be 1 to the 6th divided by 6, and then we're going to evaluate that from 1 to 3. Okay, so we'll have 1/6 u to the 6th, that'll be 3 to the 6th power divided by 6, minus 1 to the 6th power divided by 6. 3 to the 6th power, I guess before I do that, I'm going to factor out these 6's. This will be 1 over 36 times 3 to the 6th minus 1 to the 6th is just 1. So 3 to the 6th is 729. So 1 over 36, 729 minus 1. So we get 728 over 36. And we could reduce that fraction. Let's see, divide them both by 2. Going to get 364 divided by 18. Divide by 2 again, I get 182 over 9. And I think that's it. So 132 over 9 there for that, the value of that definite integral. All right, let's look at two more. The integral from 0 to pi over 4 of tangent of x dx. We haven't seen this integral yet when we have the integrand of tangent of x. Now, we don't know what the derivative of what function will give us tangent of x. It's not any of the 6 trig functions that we are familiar with. So what I'm going to do here is I'm going to rewrite tangent of x as its definition, which is sine of x divided by cosine of x dx. And then doing so, we can make a u substitution. So I'm going to let u be equal to cosine of x. When I take the derivative of both sides, I get negative sine of x dx. Now, I have a positive sign here, so I'm going to multiply both sides by negative 1, and we just end up with positive sine of x dx, which is what we want in the integral. And then I'm going to take care of these limits of integration. When x is 0, so cosine of 0 is going to give me 1, and then cosine of pi over 4 gives us root 2 over 2. So those are the new, those are the new limits of integration. We're going to have 1 to square root of 2 over 2. Sine of x dx is in the numerator. That's going to be negative 1 times du divided by u in the denominator. I'll take that negative 1 outside the integral. So we end up with du over u, or if you prefer, 1 over u du. Sometimes people like to see it that way better. Okay, so the antiderivative of 1 over u is the ln of u. And then we're going to evaluate that from 1 to square root of 2 over 2. Okay, so we have negative 1 ln of root 2 over 2 minus the ln of 1. Ln of 1 goes to 0, so we end up with, as our final answer, is negative 1, or just negative ln of root 2 over 2. Okay, and so for a final example, we have the integral from 0 to 1 of x e to the 4x squared plus 3, and then dx. We'll let u be 4x squared plus 3, du will be 8x dx. So I have an x and a dx, so this will be 1/8 du is equal to x dx. Swapping out the limits of integration, when I input 0 into the u equation, we're going to get 3. And then when I input 1, we get 7. So our new integral will be 3 to 7. X dx gets substituted in by 1/8. I'm going to just write it separated right now. Then that'll be times e to the u. And we can take out the 1/8 here. So this will be 1/8, the integral from 3 to 7 of e to the u du. The antiderivative of e to the u is just e to the u. So this will be 1/8 times e to the u evaluated from 3 to 7. We get 1/8 e to the 7th minus e to the 3rd. So that's actually, we could leave it like that. But e is a constant. If we type this into the calculator, we get about 134.568.